So welcome back. All right, so let's start with our first problem in two pointers. This looks very simple, but going to teach you one of the most important way of thinking. So imagine you are working on a system where data is continuously coming. Okay, some values are useful in those stream of data. Some values are useful, and some values are just noise, like zeros. So now your task is move all useless data means all the noise in the end, and keep useful data in the same order. So keep useful data in the same order and do it in place. We are not going to give you extra memory, because you cannot copy the whole stream in another memory then copy back. So this is a very tedious task. Okay, so let's convert this to a coding problem now. Okay, so three conditions you understand. User data should be at the end and useful data should be in the same order, and we are going to do in place memory. We are not going to take any extra memory for that. Okay, so the problem is, now this is your input, suppose, which is having some arrays 0 1 0 3 2. Okay, so we are going to move all the zeros to the end. Okay, zeros in the end, while maintaining the order of non-zero element. Means even you cannot change the order. Means 3 will always appear after 1, 2 is always appear after 3. This order cannot be broken. Remember that. So now here is the most important step. Your output that I'm expecting is like 1 3 2 0, 0. So instead of thinking move zeros to the end, let's think move non-zero element to the front. Is having is going to give the same output, right? So move zeros to end, this can be converted into move non-zero to front. Is right? Because if non-zero element go to the front, zeros will automatically go to the end, right? So let's first think of the simplest possible solution for this. I don't care about any optimization right now. So what should be our step? So step 1, I'm going to create one array. That's fine, because that is the input array, right? I'm going to create one array. In step 2, I'm going to copy all non-zero element. Okay, so once I copied all the non-zero element, so it's a new array for the output, right? So you are going to take all the non-zero element and copy in the new element. You copied it, so whatever place that is left, that is we are going to fill that with the 0, right? And fill remaining with 0. Okay, this works, this is going to work. But what is the problem? Problem is that I am going to create a new extra space. Okay, so this extra space, which is going to take actually order of n, is not required. Second criteria that I'm not going to meet, that is not in place. Okay, because since I'm using the new memory, so not in place is already not in place in this particular solution. And in the interviews, when they say in place, this solution is going to be rejected, because we are going to take, you are violating two things. One, extra space you are taking, then you are not doing the same thing in place. So now thinking, now let's think, can I do this without extra space? Let's observe the problem now carefully. We are scanning the array. Whenever we see a non-zero, okay, we are scanning the array. Whenever we see a non-zero element, we want to move it to correct position, means at the front position, right? So we need two things. One, let me write this question here also again. The problem was 0 1 0 3 2. Okay, so whenever I see any non-zero element, I want to move it to at the front, right? So we need two things. There are two operations actually. We need two things. First, someone to scan, someone who identify the next element. Okay, so someone to scan, and I need another person who can place this element. So I need again someone to place the element, right? So now we have identified from the problem there are two operations going on. We need two separate things to do this operation. Means we are already discovered a two-pointer approach. Right? So now, 0 1 0 3 2. So this is one left pointer, this is one right pointer, right? So left pointer is going to scan the array. You can take any pointer. So just normally we used to take like left pointer, right pointer used to scan the array, and left pointer tells where is the non-zero element should go. Okay, so let's do some dry run for this, then we'll do the program for this. Okay, so 0 1 0 3 2, this is my step 1. So both pointers are here at the 0 index. So left right are here. Okay, so right is as the index 0 and value is 0, right? Let me write the index also, 0 1 2 3 4. So right is at index 0 but value is 0. We are looking for a non-zero element, so we are going to ignore this. Okay, so left stays, right will move, right? So in step 2, how the position will be there? 0 1 0 3 2, and in this left is here, right has moved. Okay, so right is at the index 1 now and value is 1 now. So this is a non-zero element, so we have to swap with the left, because left is telling me where we have positioned this element. Okay, so I'm going to swap this. So what will happen this now? Let me write here. So it will be like 1 at the first place. Now 0 will come here, then 0 3 2, and now left and right both are here now. Correct? Right. Now we are going to move to the next step, step 3. So again what will happen now? Right is at 2 index. So when I'm going to scan, the right is at a 2 index. 2 is a non-zero element. 2 is a 0 element. I'm going to ignore this. So in step 3, what will happen now? 1 0 0 3 2, my left pointer is here and right pointer is here, right? Because it's 0, so I'm going to move this element to the next element, right? Okay, so now at index 3 is again non-zero element, right? So we're going to do the same operation. We're going to swap. So when I'm going to swap, then what will happen? We are going to swap this and this. So 1, 3, 0, 0, 2, right? And right is here and left will move 1 forward, right? Because next index is the 0 element, so where we can we have to update in future the new element. So left is here, right is here. Now coming to step, we are at step 3, right? So now move to step 4, right? So now we're going to move right pointer for the next element, that is again is going to point to, so it's a non-zero element. Again we have to do the swap. Okay, so now my position is 1, 3, 0, 0, 2. My right pointer is here now and left pointer is here now. Okay, so this is non-zero element, so again I'm going to swap. So this will become now 1, 3, 2, 0, 0, and my right pointer will come now here. I mean, it's a swap, so left will move once more again, left will come here and right is here. So I mean now elements are over. We have go through all the elements and loop is going to be broken, right? So if you notice something very important here, we are not moving zeros, we are placing non-zero elements at the correct place. So this is called a partitioning in the array. Partitioning means we are separating the whole array in two types. One is having only zeros and one is having some non-zero element. Correct? So this is the problem of partitioning. So if I ask you to write the pseudocode for this, so what you are going to do, you are going to left equal to something 0, and for one loop where right in array you are going to validate and say if nums dot right is not equal to 0, then we are doing the operation, right? 0 we are ignoring simply, right? If this is correct, then I am going to swap left right, and left I have to increment every time. So this is the code, right? So in this, if you see, we are not using any extra space. It's a single pass and it's a very efficient. Okay, so let me write the Java code for this now. So I'm going to type this code in the next lecture.